Hello students, I welcome you all to my channel Engineers Academy. Today it's a different kind of tutorial in which we will learn how to use Excel in our engineering labs, right? So let's say that we have a data for an experiment related to the simple pendulum, right? So as we know that in simple pendulum experiment, what we do is that um, we have a card and a mass attached to it, and what we do is that we displace this mass from its main position and then we leave it, and when we leave it we start a stopwatch and we record the time for some particular number of vibrations, right? So let's say that if I leave this and if we record a time for 10 vibrations, let's say, so we will have some time in seconds, right? So the the sole task of this experiment in our lab is that we usually find the acceleration due to gravity. So this is a very simple experiment. I'm not going to go into the details of the theoretical knowledge of the simple pendulum, but I'm going to explain uh, the the Excel point of view, that how to enter the formula and how to plot various graph for this simple pendulum experiment. So the sole purpose is that how you people will be using Excel while performing various experiment in your engineering life. So this is just an example. You can apply it to each and every experiment. So look into this tutorial as an example and learn uh, how to how to manage this knowledge to apply to various experimental data. So let's say that we have some data. Let's say that we have performed that experiment, and for a chord length of 0.6 meter, we have recorded the time for 50 swings, right? So for 50 swings, we got, let's say, 77.60 seconds. Similarly, then we reduced the length of the chord. Similarly, we can reduce the length of the chord in this experiment as well. That let's say that we increase the length, let's say, or we decrease the length. So if we decrease the length, and again we will record the time period for 50 oscillations. So let's say that we get the data that is 0.55 for 0.55 meters, we get 74.66 second time for 50 swings, and similarly so on and so forth. So this is the length, and we got this experimentally, right? So what we need to do is that we need to have this square root length values. We need to have the Meyer time period, and the Meyer time period is basically since this is the time taken by 50 swings, so the time period is basically the time taken by the only one swing, right? So what we will do is that we will divide this value by 50. So if we have recorded this value for 10 vibrations or 10 swings, then we will be dividing this value by 10. So since this data is given for 50 swings, so what we will do, that we will divide this value by 50. So we will get all this data. Then we will find all the values for t divided by 2 pi whole square. So for every data point, for every Meyer time period, we will find this value, and then at the end we will find the theoretical time period, since from physics we know that the time period for a simple pendulum is always equal to 2 pi square root L divided by G. So now the task in this experiment is to find the acceleration due to gravity. So now how to do all this in Excel? So first of all, what we can do is that we will write all these values which are required. So let me write them again. So we will write length, then square root L. So we cannot enter the mathematical expression, that is square root L, directly in the Excel. So we will use the insert equation function, right? So this is home, and then this is insert. So then insert an equation, right? So So I will click here. Let's say if I click here and then I say insert and then equation. So here we have that equation, and now we can enter that square root L value. So as we can see, this is the equation, and here we have the square root. So this is square root. So we need this one, right? This square root, and then I will click here and then I will write small l. So this is the square root L. Now we can put it here. We need it here, so we will put it here, right? And similarly, we will write the units of length. So the units of length are in meters, right? So this is in meters. Similarly, this is the length, and then we will write the time for 50 swings. So let me write that the time for 50 swings, and let me delete all this data, right? Let me delete it so that we can have more space. And since we have included this as an equation, so they cannot be deleted directly, so we need to delete them one by one. Okay, let's delete all these rows. Delete. Now this is the length, and then the square root L time for 50 swings. And if you want to put all this text in one box or one cell, so we will click on this rep text. So this is rep text, and this is time for 50 swings. So now after measured period, what we need to do is that we need to have this as the table header, right? So this is t divided by 2 pi square. So again, insert equation, and then if I double click inside this, so we need this square. Then here we need brackets, and then inside brackets we need fraction. So this will be t, capital T, divided by 2 pi. So here we have symbols. We need to find that pi symbol. Pi symbol is somewhere here. So this is 2 pi, and then we need to click here, and then we need to put square. So this is t divided by 2 pi square. So this is how we can put all these mathematical expressions. So majority of my students say that, sir, we cannot enter all these mathematical expressions, but it is possible in Excel as well. So this is t divided by 2 pi whole square, and then we ultimately have the theoretical period, right? So let me write that this is theoretical period. So for theoretical period, again, we need to have that t equals to 2 pi L divided by G. So let's have this text in the upper side of this cell, right? So we can click on this, right? So you will have time period here. So this is top align, right? So we will top align this, so we will have the space for this t equals to 2 pi L divided by G. Again, we need to insert the equation. So insert equation, and then we will write capital T equal to, and then 2 pi, so 2, and again find that pi symbol, which is somewhere here, and then we need to have the square root value, square root expression. So this is square root, and then inside square root we need to have the fraction. So this is fraction, and this is L divided by G. So 2 pi square root L divided by G, and now let's put it here, and let's make it a bit large, right? So now we need to align this. We need to align this text like this, and this time period is also in seconds. So let's copy this, Control C, and paste it here. And again, let's align all these text, and this is center align, and this is center middle align, right? So this is, so now let's make these all text as bold. So this is time period, right? And now we need to enter all this data, right? This is the experiment data. So this is 0.60. And now we do not need to enter 0.55 and 0.50. We need to enter the formula in Excel sheet. So this 0.55 is 0.05 less than this value, and this 0.50 is 0.05 meters less than this value. So what I will do is that I will put a formula, and when we want to enter a formula in Excel sheet, we need to put equal, and then I want to subtract 0.05 from this value. So I will select this cell, and the address of this cell is B11. So that is why we have B11 in blue. So B11 minus 0.05. So this gives us 0.55. Now we need to have the values until 0.20. So what I will do is that I will drag this formula. So now we have 0.15. We do not need 0.15. So I will delete this. I will select this and press delete button. So this is, we have all that length values. Now we need to have the square root of all these values. So again we need to put a formula. So I will write equal, and then in Excel when we want to have a square root, so we will write SQ. So we have two, square root pi and square root. So we need square root, and it says that it returns the square root of a number. So I will click on this square root. Either we can click or either we can press the tab button. So let me press the tab button, and then it says that select the number, right? So the number is this number, and the number is in cell B11. So that is why we have B11 again here. So I will close the brackets, and I will press the enter button. So we have that 0.7746. Now as you people can see that in this data, this value is up to 2 decimal places. So now if you people want to have all these values up to 2 decimal places, so with this formula, this, if I double click on this, is square root B11, and alternatively we can, if I click in here, so we can view the formula here as well. So what we need to do is that we need to round up this value up to 2 significant figures. So let's say if you want to round up this value up to 2 significant figures, up to 2 decimal places, so what we will do is that we will put another formula, that is round, and it says that rounds a number to a specified number of digits, right? So if I press tab button, so here the formula says that round, then number. So our number is the square root of this is 0.6, and then comma and number of digits. So comma and the number of digits is 2 after decimal place. So now we have 0.77. So now we want to apply this formula to all those values. So what we need to do is we need to drag this formula, or otherwise we need to double click here, right? So we will have all those values, that is 0.74, 0.71, 0.67. So this is how we can find the square root value of all these length values, right? And let's align all these. Now the time for 50 swings. So now this is the experimental data, right? This is not theoretical data, so we would have this data obtained from the experimental observation. So this is all that data. So let's put this data, let's enter this data. So this is 77.60, and then we have 74.66. So now this is the experimental data, and now the measured time period will be this value divided by 50, since this is the time in seconds for 50 swings, and the time period is the time in second for one swing, right? So this will be equal to this value divided by 50. So this is 1.552, and double click on this, right? So we have all those values. Now again, as we can see that here we have the values up to 3 decimal places, so we can round up all these values. So again, I need to click this, I need to edit this formula. So I will write again round, and then this is comma and up to 3 decimal places, so we will put 3. So this is round D11 50 comma 3, and press enter, and then double click this. Similarly, we need to have t divided by 2 pi whole square value. So for this we need to enter the formula. So now this will be equal to, again we need to put the formula. So this is equal to this, and then I will put brackets, then t value, this is t value. In cell number E11 we have the t value divided by 2 multiply by pi. So either for pi we need to put 3.14, or in Excel we have pi formula. So I will write pi pi and press tab. So here we can say when I write pi, so it returns the value of pi, which is 3.1415, accurate up to 15 digits, right? So pi, and then we need to close the brackets, and we need to leave this empty if you want to have the pi value accurate until 15 digits, right? So this is E11 divided by E11 is t value divided by 2 into pi, and then close the brackets, and then we need to have the squared value, right? So we will put this sign cape and then 2. So this value is not accurate, as we can see that in our formula. First what it will do is that according to the Demas rule, it will divide this 1.552 divided by 2, and then it will multiply with it. So what we need to do is that we need to put brackets here. So we need to take care of the Demas rule as well in while putting the formula in Excel sheet. So now this is 0.06101. Again, this is t value E11 divided by 2 pi. So we need to put 2 into pi in separate brackets, right? So this is, we have that value which is 0.060. So again we need to round this, right? So let me write again, we need to edit this. This is round. Let me write round, only round. So this is 0.061, and now double click. So we have all those values, 0.056 and 0.051. These are not the rounded values, right? They are using only up to 3 decimal places, right? So this is t divided by 2 pi whole square, and then the theoretical period. So for theoretical period we need to use this formula. So this is t equals 2 pi L divided by G. This is not 8, this is G, right? Remember. So 2 pi L divided by G. So this is equal to 2 multiply by pi. So pi, press tab and close the brackets, and multiply by square root. So sqrt, press tab, and then L divided by G. So this is the L value. This is the L value, and this is here in this cell I have written the G value, right? So L divided by G, or we can write this G value manually. So that is 9.81, right? So this is L divided by G. So enter. So we have 1.553. So let's round this value up to 2 decimal places as well. So again we need to write round, press tab, and then we need to put comma, and then up to 3 decimal places and close the brackets. So this is 1.5, it's up to 2, so let's put 2 here, right? So this is 2, enter. Now double click on this, right? So we have all those values, and here as we can see that after decimal place it is only 1 digit. We want to display 2 decimal 2 digits after the decimal place. So let's increase the number, right? This is how from here we can increase the decimal number, right? And let's center align them. So now we have all that data, right? Let's make a table from this. So we will select all borders. So, and let's make it at center like this. So now we have this table, and now the task of this experiment is to plot the square root L versus the measured time period, right? The time period versus the square root L, right? So let's say this is the, if we plot the period, and that is the time period versus square root, so we will have the straight line, right? So we want to have this graph. So square, as we can see that why we want to have the plot against the square root L, since we know that t is equal to 2 pi L divided by G. T equals to 2 pi square root L divided by G, and from this we can say that T is equal to 2 pi square root L divided by square root G, and we can write that this is T 2 pi divided by square root G into L, into square root L. So now if we remove this equal sign, if we remove this equal sign and this constant, so we will have the constant of proportionality. So for the constant of proportionality, this will be T is directly proportional to the square root L. So we will have the straight line relationship between T and the square root L. So that is why we want to plot T versus square root L. So now let's plot this. So how to plot this? So we need to select this data and then press the control button and then the measured time period. So this is my measured time period, and then click on the insert, and then we will click on this, right? So we will not plot this this graph which joins all the scatter points, right? So we need to have the scatter data, we need to have the scatter graph. Since it's experimental data, so the experimental data can never be joined by the solid lines. So this is in that T versus square root L. Now this is the plot, and now we want to have the axis values. So first of all, we need to have the chart title. So for the chart title is, we can have the chart title is period versus square root L. So we need to have that square root L mathematical expression. So we can copy this, right? This is, select this, Control C, and click here and Control V. So we have this. So we have this square root L, so we can put it here. Is period versus square root L. Let's make it bold. So for bold, we need to press Control and B. This is bold. So period versus square root L. We can make this bold as well. Double click on this and make it bold. So period versus square root L. Now we want to enter the axis titles. So click on this plus and axis titles. So now on this axis we have square root L. So I do not want to write something, so I want to have this. If I delete this, so there will be no space for us. So if I delete this, okay, if I delete this axis title, so we won't have any space here. We want to have the space for square root L. So what we will do is that I will write the units. So what will be the units of this? So this will be in second, and then I will copy this, and again Control C and Control V. So we have this square root L in seconds, and then this axis title is the, we can write that this is period or time period. So this is period. So double click on this and we will have that period, right? So write the period, make it bold, so Control B. Now let's make the font size a bit larger, right? So this is, and remember that always write the unit. So this is in seconds. Remember this length is in meters, right? This is not seconds, this is meters. This is meters, and I will put comma here so that, and let's make it bold. So Control select all this text and Control B, and then make it a bit larger, right? This is, now as we can see that the data starts from 0.4. We do not need to have these values on the x-axis. This is 0.1, 0.2, 0.3, and we do not need to have 0.2, 0.4, 0.6 and 0.8. So if we double click on this x-axis values, we will have this. We will have this layout which says that format axis. Now it says that bounds, right? So the bounds are from 0 to 0.9. So we want to have the bounds from 0.4 to 0.8, right? So I will write 0.4 to 0.8, 0.4 to 0.8. Similarly, if I double click on this y-axis value, so we need to have these values from 0.8 to 1.8. So from the minimum value is 0.8. So this is from 0.8 to 1.6. It's okay. We can have all those values. So this is from 0.8 to 1.6. Now, sometimes when we perform an experiment, we want to see the trend. So we want to fit a curve in our experimental data. So now we want to fit a straight line, since we know that this t is directly proportional to the square root L. So we need to have a straight line. So let's fit a straight line in this data. So how to fit a straight line? So click on this. So click on this plus and we have trend lines. So if I click on this trend line, so we will have that straight line, right? And if you people want to have the equation of this straight fit line, so again click on this arrow and then linear and more options. In more options we will have this is linear. By default it selects linear, and then we have display equation on chart. This is display equation. So this is the equation of this straight line, which is y equals to 2.0316x minus 0.0148. so this is the equation of the straight line. The slope of this line is 2.0316 and the y-intercept is 0.0148. Now this is one kind of plot which we need from this experiment. Then from this experiment we also, the sole task is to find the acceleration due to gravity.